Good evening to all. Can please someone confirm that the screen is visible and my voice is audible?
Yes, sir.
Okay, thank you. Thank you so much. Okay, so let us start the session for the week 3, okay, assignment discussion. Okay, okay. So in the last week, actually, the course is all about that how we are going for the block diagram reduction and what are the block diagram reduction techniques. Okay, the most popular technique that we are using, that is using Mason's gain formula, that we will discuss some problems based on that. And in the time domain analysis, okay, we will mostly focus on time response of the system and how to calculate the steady state error, all these things related to your assignment week 3. Okay, so without wasting time, let's move. Someone wants to join, let me add. Okay, good. Okay, so let's discuss the question number one. The question number one is in front of the screen. Okay, so how are you going to solve it? Okay, so in the question, it is asking us to find out the output y of s divided by input u of s. Okay, okay. So how to solve this type of questions? Okay, I'll use the most popular powerful concept, that is the Mason's gain formula. Okay, so try to understand. I will just tell you the shortcut, not the shortcut. This is not a shortcut. This is actually the overall analysis. If you do thoroughly the Mason's gain analysis, you will just come to a conclusion that how you efficiently solve the question in just one line or two line maximum by using just a basic idea. Okay, so Mason's gain formula. So what is this Mason's gain formula? It is showing that the Mason's gain formula is saying that if suppose I want to find out the output with respect to the input, then what is the formula is saying? You have to do summation of, let's say I'm writing some equations here, P1 delta 1 plus P2 delta 2 plus P3 delta 3, like that you can add. Okay, the numerator, this is the term, and the denominator I'm just writing delta. Okay, so first try to understand that what is P1, okay, what is delta, and what is delta 1, what is delta 2. So all these things you try to learn first. So remember, P1 is the forward path. Okay, P1 is the forward path gain. Just listen, I'll just solve this question in one line. Okay, but just to bear with me, this method I am just using. P1 is the forward path gain. What is delta? Delta is actually something like that. I'm just writing here. Delta is something, okay, 1 minus sum of individual loop gain, or you can write sum of single loop. Okay, sum of single loop gain. Okay, if single loop gain, that's why I'm just using minus. Okay, plus, I'm adding some plus here. Okay, product of, sum of product of, like that you can write sum of product of two non-touching loop, non-touching loop gain. Okay, then if I am using two non-touching loop, then I am doing the summation of all, then I am using plus sign. Then again, if I use three non-touching loop sum, then use minus sign. For every odd you just take minus sign, for every even number you just take plus sign. Okay, like that. Sum of, summation of three non-touching loop. It's like that. It can go up to like this, up to. Okay. So this is the meaning of delta. I'll give an example. This example I'll solve within this formula. So you understand what is delta. Then what is delta 1? Delta 1 is that loop which is not touching this forward path gain. Just emphasize my line. Delta 1 is something, the loop gain which is not touching, P1. Okay. Similarly, P2 is what? If there are two forward paths, then P2 is the second forward path gain. What is delta 2? Delta 2 is that loop which is not touching the second forward path. It is like that. Okay. Delta 2 is what? The loop gain of the second loop which is not touching P2. It can touch P1, it can touch P3, but it will not touch P2 forward path. Okay. So like that way. So if this Mason's gain formula is clear to everyone, let me go through this example and solve this. Okay. So if you simplify this block diagram, then this block diagram, how it will be? Just one line, you just simplify it. Summation is there, input U of S is there. Okay. And here there are two parallel paths. Okay. One is S, another is 1 by S. They are adding at this common point. So here I can write, if I add these two, then it will becomes S plus 1 by S. Okay. Then here what is happening? Another 1 by S is there. At this point, output Y of S is there. Okay. From this 1 by S point, okay, here there is a negative feedback loop is there. Okay. It's a negative feedback loop. And here also there is a negative feedback loop, and it is coming from the output Y. So this is the overall circuit diagram. Now, from this diagram, tell me what is P1. P1 is, this is a negative feedback. Okay, it is going back. These are negative going back. So this is a positive. This is one forward path. Okay, this is one forward path. Okay. So now tell me how many forward paths are there. So there are clearly, it is visible that from input to the output, if you start from input, you will reach to the output using one forward path, that is this straight line. Okay. In this path, you can reach input to the output. So only one forward path is there. So it means P1 is exist. There are no other forward path is there. That's why P2, P3 all are 0. So P1 is exist. What is the loop gain of that forward path? What is P1? Loop gain. Loop gain means just multiply the gain in the forward path. In one gain, that is S plus 1 by S, another is 1 by S. Okay, so I am writing here S plus 1 by S into 1 by S. So you find out P1. Okay, then tell me what is delta. First of all, if you find out delta 1, first you find out delta, then we will find out delta 1. So what is delta? Delta is 1 minus, I am writing here 1 minus. Okay, so first of all, you find out what are the single loop are there. How many single loop are there? Loop means what? Loop means if you start at this point, if you come back to this same point, then it is a loop. Okay. So if I start at this point, let's say this point is 1. Okay. If I start at this point, then how do I come back to the second one again? So one loop I can clearly see. If you're changing the color, you can clearly visible that this is one loop. Okay. This is the loop number 1. Loop 1. So is there any other loop is there? Yes. You can see that if you come here, 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 here and go back and reach the same point, this is another loop 2. Okay. So how many individual loops are there? There are 2 loops. Okay. So first of all, find out loop, individual loop, loop 1 and loop 2. So first of all, find out the gain of loop 1 and loop 2. What is the gain of loop 1? So you can write down L1 plus L2, because there are 2 individual loops. That's why L1 and L2. In place of L1, what you write? L1 is nothing but how much? Can anyone tell me what is L1?
1 plus 1 by x square. Negative will be present.
Okay, thank you. So negative, this will be s plus 1 by s into 1 by s. Okay. Similarly, L2 is how much? L2 is negative because the negative feedback is there. So it will be s plus 1 by s. Okay. So you can put these values here. Similarly, if you go to the third point, this one, this part is over. Now, what is the sum of two non-touching loop? First of all, there are two loops are present, L1 and L2. Is these two loops are non-touching? Non-touching means there should not be any common point should be in between loop 1 and loop 2. So, but you can see that the loop 1 and loop 2 is touched at this point. Okay, this point is common to both L1 and L2. So, in this problem, L1 and L2 are not non-touching. They are touching each other. That's why these two, this part is 0, and the rest into this part is also 0 because there are only two loops. So, three loops are not exist. So, what is there on the denominator part? Delta is, you can write down, this is the value of delta. Okay, please someone please unmute yourself, mute yourself. Okay, so once you find out delta, then your target is that you have to find out delta 1. What is delta 1? Loop gain, which is not touching p1. So first tell me, p1 is the forward path. Okay, one forward path is there. Out of these two loop L1 and L2, which loop is not touching the forward path? Every loop is touching the forward path, right? So that's why L1 is touching the forward path. So that's why you find out in this delta, you would write down like that, 1 minus L1 plus L2 is the total delta. But here delta 2, how can you find out? You can see that which loop is non-touching. All the loops are touching. That's why delta L1 is 0, L2 is 0. If L1 is 0 and L2 is 0, so what is delta 2? Delta 2 equal to 1. Okay, because L1 and L2 are not touching. They are touching the forward path. That's why they should not come in the expression. That's why L1 is non-touching, L2 is touching, L1 is touching, both are touching. That's why both cancel, both are equal to 0. So that's why in this delta, if you put L1 and L2 0, you will get 1 minus 0 is 1. So delta 2 is 1. Sorry, delta 1 is 1 because delta 2 does not exist. Okay, this is delta 1. All of you understand this question, how I solved it? Okay, you will be clear. Let me solve another question. You will be clear by yourself. Let me solve this question number 2. This is the same question. I will find out what is C of S divided by R of S by using Mason's gain formula. But I will solve this question in one line. I will not write anything. CS by RS. Okay. Tell me the direct answer. I am just writing here. Numerator by denominator. So first tell me, just I am writing the formula here for your convenience. P1 delta 1, P2 delta 2 divided by delta. Okay. First of all, tell me what is P1? P1 is the forward path gain. How many forward paths are there? So you can clearly see that there is only one forward path is there. Okay. So if the one forward path is there, what is the loop gain of that forward path? You can write directly G1, G2, G3, G4. This is your P1. Okay, directly I am writing. Before writing delta 1, delta 2, first you write the denominator part. What is delta? Delta is nothing but 1 minus loop gain. How many loops are there? How many loops? Let me write down the loops. Let me change the color for you. Okay. So how many loops are there? Let me call this L1. Okay. Let me call it L2. Okay. Because this is a loop. Okay. That's why this is L2. So if you start from this point and go like this, and come here, and just use this. One second. Let me use the laser pointer. Yes. Okay, okay. Now you see, this is one loop because you'll start from here and you'll go from here. This one L1 I'm writing. This is another loop because it is starting from at this point and it is coming here and it is going back. Similarly, if you start from here and if you come here and it is coming, this is another loop. So let me write that loop is something L1, L2 and L3. This is another loop L4 because you will start from here and go back and come to this -1. So these are the loops. Okay. So how many loops are there? You can write the loop gain of all the loops. L1, what is the loop gain of L1? -2. Okay. What is the loop gain of L2? You can clearly see what is the loop gain of L2. Okay. So this is this starting from here and going. So simply L2 equal to how much? Minus,
minus G4.
right. Thank you, sir. Minus G4. What is L3? L3 is something you can write down. L3 is minus G3, G4. Similarly, you can write down L4. What is L4? L4 is something minus G2, G3, G4. Okay. So these are the four loops. Now tell me, out of these four loops, so these are the individual loops. You can write down L1 plus L2 plus L3 plus L4. Now out of these four loops, you just find out how many loops are non-touching each other. So you can see which loops are non-touching each other.
L1 and L2.
L1 and L2. L1 and L2 find L1 and L2 combination. So these two
Sir,
are
L1
coming.
and L3
L1 and L3 is another combination. Is
and
there?
L1 and L4.
So
No,
L1 and
no.
L4 are coming, are joined at this point because there is a common node between them, L1 and L4. So L1 and L4 are not. So one you can write down, one is L1 L2, another is L1 L3. These two are the non-touching loop. Okay, if these two are non-touching loop, then you have to write the sum of all the non-touching loop. Okay, because they are product, so sum of all the non-touching loop L1 L2 plus L1 L3. Okay, so how many, is there anything three loops which are non-touching each other? No, I cannot see that there are three loops which are non-touching. So here you already find out delta you find out. Okay, so once you got delta, then come to the numerator part. Okay, so tell me, in that forward path, which loop is not touching that forward path? All the loops sharing the common forward path. Okay, because L1 is sharing this path, L2 is sharing this forward path, L3 is sharing this forward path, everyone is sharing this forward path. That's why in this formula L1 0, L2 0, L3 0, all are 0, only 1 will be present. Okay, so P1 delta 1 is 1, delta 1 is your 1. You find out P1, multiply with delta 1, because P2 and delta 2 will be 0 because only one forward path is there. That's why P2 delta 2 equal to 0. So your answer should be this much. You can write and solve this, put the value of L1 and L2, you'll get the answer. Okay, in this way actually we approach, because sometimes what will happen, delta 1 will be exist. Okay, there are two forward path will be sometimes will be present in the questions. Okay, you find out P2 and you see, first of all write out delta. From delta you just make a theory like this, which are touching and which are non-touching loop, and check that in the forward path which loop is non-touching. Okay, so by addressing this you can find out P1 delta 1, P2 delta 2 and delta. In that way you can write the transfer function. It will not take that much time. You practice at least 10 questions, then it will just don't do anything, just within one page or one half of the page somewhere you can write the answer. Okay, so this is the way you can solve the questions, okay, from Mason's scan formula. Let me give my favorite question. Okay, these are because this is a very favorite question of the control system. Okay, this is a practical system. Let me define this question for you. Let me question give you. Let's say this is the forward path transfer gain. Okay, and here let's say I'm using a summing block. the practical control system. And remember that control system mostly are negative feedback system. Okay, because why negative feedback system? Because control loops means control system is a low pass filter. Okay, mostly all the it is a negative feedback system are mostly 90% feedback system are negative feedback system, because positive feedback system mostly make the system unstable. Okay, that's why in control system, if you see come across, you will see that negative feedback system are most common. That's why I'm just putting a negative feedback here, and here I'm just giving a feedback path gain h of s, and here I'm just taking a feedback from the output y of s. Here I'm giving plus input u of s. Okay, now this is a basic question everyone knows, but using Mason's-Gain formula, can anybody tell me the what is the output y of s divided by u of s? So first tell me how many for p1 delta 1, in front of you write down p1 delta 1 divided by delta, okay, plus p2 delta 2, okay, you just write down this and try to solve. So what is the forward path? For one forward path you can see here, there is one forward path. Let me change the color. Okay, so this is the one forward path which gain is g. I'm writing g directly, but I don't know what is delta 1. I will calculate delta 1 later. First tell me what is delta. Delta is the how many loops are there. So there you clearly see that there is only one loop exists. Okay, it's a negative feedback system. So what is the gain of that system? Minus gh. Okay, this is your L1. L1 is minus gh. So you can write down what is delta 1 minus gh. Okay, then is there any other loops are there? No. L2 is 0, L3 is 0, everything is 0. Now you just see that in that forward path, is the loop L1 is touching or not touching? Forward path is G, L1 is minus GH. So you can see clearly that G is present in the loop. Okay, as G is present in the loop, you can put L1 equal to 0 in this denominator. Here you can write. So G P1 delta 1 is directly 1. Okay, so because it is touching that loop, it is not a non-touching loop. So what is the answer? G divided by 1 plus GH. Okay, so this one you can solve by using Mason's-Gain formula. Okay, let me ask you. Okay, let me ask you another question. Let this point is E of s. E of s is the error. Okay, because this is summing block. Input minus feedback is called the error. Okay, so I am just asking you to find out E of s divided by U of s in one line. Can anybody tell me what is the answer? E of s divided by U of s.
H of s into y of s.
H of s into y of s. Okay, okay. Let me E of s by. I'm just asking the transfer function. Okay, let me solve. I'll come back to this slide. Okay, I'll come back to this slide. Let me move to the next slide. I have asked you E of s divided by is the error with respect to input. Okay, so how to find out that? So first of all, tell me from this block diagram, what is this point? What is this point gain? This point gain is nothing but y of s into h of s. Okay, so now E of s is something, you can write here E of s is something, you can write E of s is nothing but u of s minus y of s into h of s divided by u of s. Okay, next u of s minus what is y of s in terms of u of s is g divided by 1 plus gh. We already calculated that. So g divided by 1 plus gh into u of s, okay, into h of s divided by u of s. So this U of S, now it cancels here, here and here. So what is left now? 1 minus G divided by 1 plus GH, okay, into H. Okay, H of S means H, you can write. Simplify this one. This will be 1 plus GH minus GH divided by 1 plus GH. So GH cancel. This will be, answer will be 1 divided by 1 plus GH. So answer will be 1 divided by 1 plus GH. But I don't want to solve in that way. If you know Mason's-Scain formula, you can directly write the answer. Okay, let me come to a next slide, fresh slide. Here, let me draw the quickly. This one is G, this one is H, this is feedback, this is Y, this is summing block, okay, this is U, this is E. So everything with S is there, I'm not writing for simplicity. Okay. Okay. Now tell me, what is E of S divided by, okay, this negative feedback is coming here. Okay. So E of S divided by U of S. I'm directly asking you. First tell me how many forward paths is there from U of S to U of S. Input is U of S. You want to reach E of S. There is only one forward path. U of S, because this is right hand side, this is also right hand side. So if you start from U of S, you will reach at E of S, but having a unity feedback. Nothing is, sorry, there is no gain is there. So gain is 1. Okay. So directly your P1 delta 1 plus P2 delta 2 by delta, your P1 is 1 because unity gain is there from US to E of S. Nothing is there. There is single line. So unit gain is 1. So simply you can write P1 equal to 1. So then you find out what is delta. Delta you already find out from the first formula, first question. So delta is nothing but minus GH. Okay, this is delta. Is there any loop which is touching the P1? Non-touching. I'm just asking, is that this loop L1 is non-touching the forward path? Yes, it is touching. At this summing point, they are all touching each other. That's why this delta 1 is also 1. So what is the answer? 1 divided by 1 plus GH. So you can directly write U of S divided by U of S is 1 divided by 1 plus GH. If you know this formula, then from this formula only, the steady state error we can find out. The steady state error of any system can be derived by using this E of S, because steady state error is nothing but E of S. Okay. So now, if you understand these two questions, okay, let me move to a questions for you. Okay. So question number 2 is over. This question is a famous question. You can try to understand that how I'm solving using Mason's-Scain formula. Okay. So now this is another question number 3. Can anyone try to solve it? Can you try to solve the question? First of all, tell me what is P1? How many forward paths are there?
The two forward path.
Yeah, tell me, sir, what is the gain of these two forward paths?
Sir, P1 is 1345 and second is 161.
1, 3, 4, 5 is 4, 3, 12, 60. P2 is how
And
much? 1 into 6, 1, so 1.
161.
It is 6. So you can write down directly formula P1 delta 1 plus P2 delta 2 divided by delta. Okay. So if you know P1, P2, immediately you calculate what is delta. Delta is how many loops are there, you can find out. What is how many loops are there? This is, let me, L1. There is another loop. Here is L2. Here to here another loop is L3. And if you start at this point, if you go here, here, this one and this one, is this is a loop or not?
Yes.
So you can see L1, L2, L3, L4, L1, L2, L3 and L4. You find out the gains of all these things. Okay, this is up to you. I am not writing here. So first tell me, out of this L1, L2, L3, L4, which are non-touching loops?
L3 and this one is both are L3.
No, if L3 is, sorry, let me this one L1. Okay, L1 and
L1 and
L3.
L3 they are not touching.
Okay, L1 and L3 are non-touching. Non-touching. I'm writing non-touching. So, so you can write down that directly 1 minus L1 plus L2 plus L3 plus L4. Then plus how many non-touching loops are there? Only one combination, that is L1, L3. Okay. So once you got delta, now you find out what is delta 1. Delta 1 is that loop which is not touching the fast forward path. So fast forward path, you can see that all the loops are touching the fast forward path. Okay, that's why delta 1 equal to 1. Okay, because all these loops L1, L2, L3, L4, L1, L3, this combination all are touching the forward path. That's why these are 0. So what is remaining? 1 minus 0 is 1. Next, what is delta 2? Delta 2 is the loop which is not touching the second forward path. Second forward path is something like that. Okay, then which loop is non touching? L2.
Sir, L1, L2, L3.
L1, L2, L3. No. L1 is touching at this point. L3 is touching at this point. But you can clearly see that L2 is not touching the second forward path, right?
Yes, sir.
You understand now? Because at this point the same. This L1 is touching at this point. L3 is touching at this point. So the forward path is above, it is going. But L2 is not touching at anywhere in that forward path. If it is not touching, then delta 2 is how much? What is the loop of that? What is the loop of this? This is how much? You can see here in this formula, write down L1 is touching, so this will be 0. L2 is not touching, so it will be exist. L3 is touching, it is 0. L4 is touching, it is 0. As L1 is touching, so this is also 0. So what is remaining? Delta 1 equal to 1 minus L2. So this is your delta 1. So put in that formula delta 2 is how much? 1 minus L2. And you solve this question.
This is delta 2.
This is delta 2. Sorry. Delta 2 is 1 minus L2 because delta 1 is already calculated, that is 1. So delta 2 is 1 minus L2. So put all the values now, you will get the answer. Okay, so this is one question. I want to show that how we can calculate delta 1 and delta 2, which are touching and which is non-touching, and you can immediately calculate from delta. Everything we just calculate from delta. First you calculate delta. From delta you see that which is touching and which is non-touching. Accordingly you make it 0 and find out delta 1 and delta 2. Okay, I think everyone is clear. This point everyone is clear. Let me go to further next slide. Okay, question number 4. Okay, let me give question number 4. Okay, so I'll this question number 4 will be very important. Okay, very important. I'll use lots of shortcut to solve this question. Okay, this is one of the most important question. Okay, people should do mistakes. I'll tell you how. Okay, let me give a question to you. 100 divided by s into s plus 10. This is the forward path gain G. Okay, now this is your output y of s. This is your input u of s. Now I'm just doing a negative feedback. Okay, this negative feedback hs is 1 divided by s plus 5, and here this feedback is coming from the output. This is a negative feedback. Okay, and this is a negative. I'm just writing that negative means you understand that this is a negative feedback. Now I'm asking the question to you, find out the steady state error. What is the steady state error of the system? So remember 1, 2, 3 questions. Okay, so first point you remember, these are very important points, try to understand. Steady state error, whenever a question will ask you steady state error, steady state error is only applicable for a unity feedback system. Unity feedback, that too negative. Okay, as I told you, control system mostly are negative. So remember that unity feedback means there is a unity negative feedback system. Okay, unity negative for understand writing. So steady state error is only applicable for a unity negative feedback system. Okay, if a system is non-unity feedback negative system, you cannot find the steady state error directly. Okay, so first tell me in this question, it is a unity feedback system or it is a non-unity feedback system? Whatever the question I given.
So non-unity feedback system.
So I'm just writing here G. Here is G is there, and here H is there, and H is having a value of 1 by S plus 1. It is H is not 1. Okay, that's why it is a non-unity feedback system. Okay, this is a non-unity feedback system. This is U, this is Y. If it is a non-unity feedback system, then you cannot find out the steady state error directly. What you do, you first convert this non-unity feedback system into a unity feedback system. So how can you do that? You can do easily by adding a positive feedback. I'm adding a positive feedback here. This is a positive feedback, and in this I'm adding a negative feedback. So this positive feedback and this negative feedback get cancel each other. This is a unity 1, this is a unity 1. So one positive feedback I added, one negative feedback I added. Now, so keep the negative feedback and solve the question. So first tell me, forget about all this. You understand that you have to add one positive feedback and you have to add one positive feedback and other negative feedback. So first tell me, for this question, what is the transfer function? Y by U. Already calculated in the last slide. This is G divided by 1 plus GH, right? Okay, I told you in the last class how to directly find out the transfer function. Okay, by looking at this. This is the system I am giving. So G is there, H is there. This is summing block. If it is given like that, then how to directly find out? First you write the G. Okay, then what you do, as it is a negative feedback system, it will be plus. Okay, then what you do, in that G, write down this G here, denominator. I am writing D. Whatever the G is there, multiply with this GH. You will write here like that. Okay, I told you in the last class how to find out. Okay, but now suppose you know that for this system, you know that the transfer function is G divided by 1 plus GH. So I am replacing this block by a single block whose transfer function is G divided by 1 plus GH. Now in this system, I am adding a positive feedback. Here I am adding a positive feedback, and here I am adding a negative feedback. Okay, but I told you that for steady state error, you need to convert into a negative feedback system. It means whatever the remaining lower portion you keep it, the upper portion you try to solve it. Okay, so I am solving the next slide. Okay, let what I did here, G divided by 1 plus GH I have written, and here what I did, I am adding a positive feedback system. Let I am adding a positive feedback system. This is a positive feedback system. Can you tell me what is the answer for this question? What is the transfer function? Y divided by U. So whatever is there, you write
So
down. G divided by 1 plus GH. You just write down this one first. Whatever in this block you write down. Then what you do is the positive feedback, you subtract negative sign. What you subtract? Whatever is in the numerator, you subtract that one. So this is the answer. So this is the answer, Y divided by U. If you solve it, you will get this same answer. Y divided by is how I write it, again I am just letting you do. So what I write, Y divided by U, how I write it? First of all, whatever this inside the block, whatever the expression is written, you just write down G divided by 1 plus GH. It is a positive feedback system, means you have to subtract. What you have to subtract? Whatever this in the numerator, you just subtract here. So we will get the answer. Suppose this is a negative feedback system. Okay, in place of this plus, if it is minus, then what you do? You have to add that. Okay, so but I have to solve it for positive feedback because I want to keep that negative feedback for finding out the steady state error. So if I am solving this one, this is my answer. Now what is remaining? This is the block
So
diagram.
it is a minus G, na, sir, now.
Yeah, now it is minus. So now the transfer function remain how much? G divided by 1 plus GH minus G. Now there is a negative feedback system is there because we already added a positive feedback. For positive feedback we solve it and find the transfer function. Now this negative feedback is there. This is U, this is divide Y. Now the earlier question, whatever the question I given, this question, you convert this system because this system is a non-unity feedback system. Now after solving you got the unity feedback system. Now you solve that, solve this value G divided 1 plus GH minus G. Now you got a unit feedback system. Now you can able to find out the steady state error of the system because steady state error is only applicable for a non-unity feedback system. And remember, whenever you are calculating steady state error, you are always prefer open loop transfer function, not the closed loop transfer function, and that too it is for a negative feedback system. Means there is a negative feedback system is there, unity gain. Okay, you can able to now find out. And how can you find out the steady state error? I don't want to consider the closed loop, whatever the transfer function it is given, open loop transfer function. Now for this expression, what is the open loop transfer function? Open loop transfer function is G divided by 1 plus GH minus G. You solve this, and from this open loop transfer function I will tell you the shortcut how to find out the steady state error. You understand that how a non-unity feedback system is converted into a unit feedback system for finding the steady state error. Everyone is clear? Then I'll proceed. If any doubt, then tell me, I will explain it again, but you try to understand that what I am doing. Any non-unity feedback system is there, you add a positive feedback, add a negative feedback, solve for the positive feedback, keep the negative feedback because it is required to find a steady state error. Okay, so the expression I have already written, how I come to this expression G divided by 1 plus GH minus G. So my previous question, G is this much, 100 divided by this one is your G, this one is your H. Okay, solve this expression G divided by 1 plus GH minus G and tell me what is the answer. What is G divided by 1 plus GH? Can anybody solve this and find out what is G divided by 1 plus GH? G is how much?
Sir, 100
Yeah, so tell me.
100 into S plus 5
S plus 5
divided
divided by
S whole into S plus 10
S whole into S plus 10
into S plus 5
into S plus 5
plus 100.
plus 100. Is everything is getting the same answer?
So we have to solve this all the loop, or we have to find only this open loop transfer function?
Only open loop transfer functions. Solve this
Okay.
G divided by 1 plus GH minus G.
Okay, sir.
I'll do this. I'll do this for you. Just okay, here I'm writing directly. G is how much? 100 divided by S into S plus 10 divided by 1 plus G. 100 divided by S into S plus 10. What was the H I written here? 1 by S plus 5. So 1 by S plus 5 minus again G. 100 divided by S into S plus 10. Now solve it. So this will be how much? I think you'll get something 100 into s plus 5 divided by s cube plus 15s square minus 50s minus 400. I think you will get this final expression is like this. Okay. This is the open loop transfer function.
Yes, sir. That will become, sir.
Okay. Okay. If we get this, then I need the open loop transfer function. I told you to find out the steady state error. No need to find out the closed loop transfer function. Let's suppose someone, let's say it's a 10 mark question or 15-20 mark question. Then suppose you are not appearing a numerical examination. Then suppose you have to solve it, lengthier process. Then what to do? How to find out the steady state error? I already did in the last slide. You just see here. Here I already written what is E of s divided by U of s. E of s by U of s is 1 by 1 plus gh, right? Okay. Then what you do here in this question, in this example, you find out directly what is E of s divided by U of s. Okay. But you know in Mason's-Kern formula you can able to solve this question. What is the answer I have written? E of s divided by U of s. Already we got the answer 1 divided by 1 plus gh. Okay. Solve it. Okay. Find out 1 divided by 1 plus gh. Then what you do? You have to multiply U of s here because E of s is now nothing but 1 divided by 1 plus gh into U of s. Okay. Then what you do? For steady state error, what you do? Limit you take s tends to 0, then s into E of s. You find out. It depends on now. Now the steady state error completely depends on the input. Okay, which type of input you are applying. Okay, now that is the point I want to convey, that the steady state also depends on the which type of input. How many types of inputs are there in control system? You can apply impulse input, you can apply a step input, you can apply a ramp input, and you can apply a parabolic input. So let me classify all this here. Okay, for your simplicity, how many inputs are there? I'm writing here. So I'm writing input. So how many types of inputs are there? First of all, we are not taking impulse input because for the impulse input the amplitude is infinity, so we are not considering that because it is not a bounded system. As the input is not bounded, the output is also not bounded. That's why impulse response we are not doing for the steady state error analysis, but impulse input you are doing for the transient analysis. Okay, that's why for steady state error you don't consider the impulse input. That's the other three inputs I have to take. What is the first input? Step input. What is the second input? You have the ramp input. What is the third input? Is the parabolic input. Okay, so these are the three types of input. Now, a step input, how it is written by U of t. Okay, what is the RAM input? How it will be written by R of t. Okay, but R of t I am now expressing in terms of U of t, so this will be T U of t. Okay, how parabolic input is written? It will be T square by 2 U of t. These are the standard forms. Let in the question, let me come back to the question to make you understand. Let's say, uh, no, let me understand you here. So let's say I'm giving, in this question I'm giving a step input. Let I'm giving a step input of amplitude 5. So what is the meaning of this statement? Step input of amplitude 5 is that, so step input, so input is step, amplitude is 5. Now what is the expression? So this will be, now the expression is 5 u of t. Okay. Next, I am giving another input of ramp input of amplitude. Let's say 2, ramp input of amplitude 2. So what are the expression of the inputs now? 2 into t into u of t. Okay, it means just I am adding one term here, that is a and a. What is the meaning of a? A is called the amplitude. Suppose I am giving you the example, I am adding the third input. Let in the question they have given you a ramp, a parabolic input is given by 6 into t square. Then if it is given like that, parabolic input is 6 into t square, but the standard formula is what? A into t square by 2 into u of t. So you have to convert, add, divide by 2, multiply by 2, make into the standard formula. Okay, u of t. So now the amplitude is how much? 12. So a is now here 12. You understand? Based on the input, these are the standard formula of the input. Find out what is a. Okay, so once you clear that the steady state error depends upon the input, first of all you identify what type of inputs are there, and what is the amplitude, what is the value of a. Okay, this is the most important point while finding out the steady state error. Okay, now coming back to the next slide, I will just do a comparison here. So what is the comparison? I am just writing two things, one is type, one is input. You try to understand, these are all the shortcuts. I will never solve any steady state error question by using hand. I'll just look at the question and tell the answer. So first of all, let me classify, there are two things. What do you mean by type of the system, and what do you mean by input of the system? You understand now what is input. There are three types of input. One is step input, which is written by a into u of t. Another input is ramp input, so a into t into u of t. Another input, parabolic input, which is a into t square by 2 u of t. These are the standard formula of the input. But what do you mean by type of the system? Suppose I am giving an example. Tell me what is the type of the system. So let me 1 divided by s into s plus 5. If this is my g transfer function, then tell me what is the type of the system.
Sir, 1.
Type means you have to find out the number of poles at origin. Okay, so how many poles at origin, that gives a type. Let me add someone. Actually someone is a long time user waiting. Okay, let's come to the type of the system. Type means you have to find out the number of poles at origin. Okay, let me give an example. Suppose there are two types of questions. There are lots types can be classified like this. I am saying here, for this example, whatever I given, the type is 1. Okay, if I am given example 1 divided by s plus 2, this is another g. Here you can see the type is 0. Here another type of question, let me give you 1 divided by s into s plus 5 into s plus 6. Here what is the type of the system? Again
Sir, 1.
Again 1. So once you find out the type of the system, you know how to find out the type of the system. Then you compare. Okay, let me write here type 0, here type 1, and here type 2. Okay, so first of all, if in the question, because steady state error only calculation, we require the transfer function g. We don't want the closed loop transfer function. Now from that transfer function, you find out the type of the system. Let I have classified the type 0, 1, 2. Okay, it can be anything, g can be anything, type can be 0, it can be 1, it can be 2. Now on the right hand side, you write down the input like this. Okay, I'll solve this question number 5, but you just understand this what I'm saying. If this type and input is matching, for type 0, if input is step input, remember, if type 0, if the input is step, then the steady state error will be 1 divided by 1 plus k. Okay. For this second type of system, if your type 1 will be matching with your input, which type of input? Ramp input, then the steady state will be 1 by k. Okay. If for type 2, if these two are matching, this is matching, then again the answer will be 1 by k. Okay. But for other system, okay, in some cases what will happen, if your type is greater than input, type is greater than input, or in the other case, type is less than input. Type is greater than input means what? In which case the type is greater than input? Let's say type 1 and input is step input. In this case, because I am just paralleling it, if it is 0 means this will be 0, if it is 1 means this will be 1, if it is 2 means this will be 2. So it means type is greater than input. Type, let's say 1 is greater than input. So if these two, they mean you are matching these two. Okay, in that case, or if it type is less than input. If type is greater than input, then steady state will be 0. If type is less than input, then the steady state error is infinity. Okay, you understand this point or not? You are not getting?
Yes, sir. We will.
Yes, sir, understood.
Okay, so type is greater than input, steady state will, by looking at the question you can say, don't do anything. Okay. Let me give a question to you. Okay, here I'm writing the question. Because I told you the concept, if you not solve a question, you cannot understand. Let me give an s square plus s plus 5 plus s plus 10. Okay, first tell me what is the type. Type is 2. Okay, let's say I'm giving an input for this system. Input is 5 into t into e of t. Then first tell me whether steady state error will be exist or not, and if it is exist, what is the steady state error?
Sir, actually steady state error not exist because of type is greater than input.
If type is greater than input, then steady state error will be 0, right?
Yes, sir.
So answer will be 0. Okay, I'm just giving an example. Suppose if type is 1 now, sorry, if not type, I'm just saying if this will be s now, what will happen? Type is 1, then what is the steady state error? First of all, tell me, exist or not? How can you compare? You can see here type is 1. Here on the input also you have to see 1. How it is 1? T to the power 1. Okay, so like that you think 1 is matching with 1. That's why steady state error will be exist. And for this is a type 1, the steady state error will be 1 by k. What is k? K is called the DC gain. What is DC gain? In the transfer function, you just forget about this s. Whatever the remaining part is there, you just put 0. So what is the remaining part is there? 1 by 5 into 10, 50. So k is 50. So 1 by 50. So steady state error is 50 for this question. Okay, let me give another question to you. Suppose this will be s square. Okay, and here I am giving input. Input is now, let me define input, t square into e of t. Now tell me, what is the type of the system?
Sir, type 2.
Type 2. And here you see the input. What is the type here? Input t square is there. So 2 is now equal to 2. It means if 2 is equal to 2, your steady state error will be exist. What is the steady state error for 2? 1 by k again. And what is k? K is called the DC gain. Forget about this s square. And again what you
50,
do?
sir.
Again 50. The answer will be like that. But you see carefully. Here one thing I am missing. I told you that when a parabolic input is there, you convert it into the standard formula. You first multiply 2 and here you multiply 2. Okay, so now whatever this 2 is coming here, again this 2 will be multiplied with the answer. So it will be now 100. Understand my point?
Yes, sir. Understand.
Yes, sir.
So in this way, actually by looking the question, you can tell the answer. Okay, don't need to solve. Because why I'm saying that? Because in questions, the control system in GATE exam also, in numerical exam also, they will never go beyond the third order system. They will never ask you for what is that. If they will ask you, then also you can see whether type is greater than input or type is less than input. In one case, let me give an example. Suppose your type is here S, and here the input I am giving this one. What is the answer? If this is the input and this is the type is 1,
Sir, infinite
so answer
does
will be
not.
directly, you can see answer is infinity, means steady state error does not exist. Okay. Okay, so in this way you can solve the questions. I'm just giving a final question to you. Okay, for the steady state error. Okay, so I just want to see that how much you understand it. 10 divided by s plus 1 divided by s square into s plus 2 into s plus 10. Okay, now this is the transfer function is given. Now input I am writing here. Input is given to you 10 plus 5t plus t square by 2. Now tell me, if this is the transfer function, this is the input, find out the steady state error, ESS. So what is the answer? By looking at, don't solve anything. Here the input is a combination of all the three now. Now what you do in this case, you just apply superposition theorem. First you apply 10, find out the steady state error. If I apply 10, input is 10 means 10 into t to the power 0, right? 10 means 10 into t to the power 0. Okay, what is the type here now? Type of the system is 2.
2.
So input, if we apply 0, then type is greater than input. So answer will be for the first input how much? 0.
0.
Next plus. For the second input, here what is the type? Type is always 2, and here now input is changes to 1. Then type is again greater than input. So answer will be for 5t how much? 0, because here it is 1. T to the power 1 and type is 2. Type is again greater than input. So for 5t, so for this g, for the steady state error 0, right? Type is greater than input. Understand?
Yes, sir.
Next
Yes, sir.
question.
Understand.
Yes, sir.
Now you have the third input. Now you check the type. Type is 2, input is 2. Okay. Now there is some steady state error will be exist. What is the value of that? This value will be 1 divided by k. Okay. So 1 divided by, what is the steady state gain? Forget about this s square and find out, put s equal to 0 everywhere. So 10
Sir, 2 actually.
divided by 20. So this will be k. You just find out k. First, what is k? 1
Sir,
divided
2
by,
come 1 by 2.
okay, so 1, okay, 1, 10 by 20, this will be 10 by 20, so answer will be 2, right? So here now we add 2, so the answer will be 2 only. So this is the steady state error. For the combination of input, to find out the steady state error and add it individually, you will get the total answer. You understand this one?
Sir, I have a one question, sir.
Right.
Sir, if their present type is greater than or input, then total answer will be infinity comes.
Yeah, because 0
Anyone
plus,
in?
yeah, anyway, you can add infinity somewhere. 0 plus infinity is infinity. So answer will be infinity.
Okay, sir.
Okay. In this case, suppose if I'll reduce this one. If I'll make this not in place of s square, if I make s, then what will happen? For the first term, it will be 0. For the second term, there is some steady state error. For the third term, it will be infinity. So something you have added infinity, the answer will be infinity. You understand?
Yes,
Yes,
sir.
sir.
Understood.
Next, if you understand, then a similar type of question. Let me, but I don't want to confuse. This is a very important concept. Okay. Then let me. This is the G I given. Let I am adding the first input 10 u of t. What is the steady state error? Now tell me what is the answer. You can tell by looking at the question. Tell me the answer. What is type? Type is 0. Input is also how much? 0, because
Zero.
t to the power 0, right? 0 0 matching. So
Yes.
there is some steady state error.
Sir,
What is the steady
50 by 51.
1/1 sk.
Yes. 1 divided by 1
1
plus
plus
k,
k.
right? So 1 divided by 1 plus k is how much? DC gain 1 by
1 by
50.
50.
But you have to multiply this 10 also. Don't forget. Okay.
500 by 51.
Okay. Whatever it will be. Okay. 10 divided by 10 into 50 divided by 51. So 500 by 51. Next, I am just applying another input. Let's say I am applying 10 into t square u of t. What is the answer for the same transfer function? Can
Sir,
see.
1000.
No. Type 0.
The
This is
error
type
not
0.
Oh, sir, infinity.
Yeah, you have to first convert this t square by 2 into 20, right? Now you see here type is 2. Here the input is greater than type, so answer will be infinity. Don't calculate anything. Okay. Otherwise, if this question is there, if you don't know the shortcut, how to solve the question, to find out E of S divided by input U of S. Okay. Then what you do? You have to put limit S tends to 0, S into E of S. Okay. Then what is limit S tends to 0, S into E of S is how much? E of S. E of S is how much? E of S, this one is your E of S by UF. E of S, you have to multiply here E of S, right?
1 by G.
Okay, whatever. You know how to solve this. If you don't know the shortcut, you have to go the lengthier process. Just I'm trying to say that how can you solve it? Oh, okay, without using any pen and paper. Okay. Then if this is the case, I have just given some questions to here. Can you find out the question number 5 answer? Anyone? What is the question number 5 answer? First of all, tell me, in this question number 5, he is saying that the steady state error is 0.05, right? If the steady state error is 0.05 and he is applying a unity step input means t to the power 0, right? Yes or no?
Yes, sir.
It means here you can see 0 is there and steady state error is there. So what is the type of the system?
So 0.
Yeah,
0.
the type of the system will be 0, because if 0 will be matches with 0, then only in that case steady state error will be exist. That's why the type of the system is 0. Next, come to question number 6. Where is the question number 6? Okay. So what is the position error constant Kp? So remember that position error is constant when 0 is matching with 0. In that case, the steady state error is how much? 1 divided by 1 plus k. This k is called the Kp. This k is called the position error constant. When this type equal to 0, input equal to 0, in that case, that k is called the position error constant. So k, how much? What is the k? K is called the DC gain. Directly you can find out by looking at the question. What is the DC gain? Because you know na, I'm writing here, I'm just solving here the different pen, you can identify it later. So those who are not attending the class, I don't know, they might be. What is the answer? 1 divided by 1 plus Kp is the steady state error. The steady state error in the question is giving to you 0.05. Okay. So now you solve this question, find out Kp. This is simple question. Okay. Now, if you understand the steady state error very well, then let's move ahead. Okay. Question number 7. Okay. Let us solve one question. Okay. This is question based on the time response. Okay. So now for this question, you just find out C of S divided by R of S. Can anybody tell me what is C of S divided by R of S by looking at the question? I already told you the shortcut. Okay. So whatever is written, you just write down G divided by S into S plus 3. Okay. See the feedback type system. This is negative feedback. So you have to add. What value you have to add? Whatever in the numerator you add here. So this is the answer.
Plus
Okay.
G.
Okay. So now this is your C of S divided by R of S. Okay. You solve this, and after solve it, what the answer will be? G divided by S square plus 3S plus G. This is your closed loop transfer function. So from this transfer function, you know that whenever you have read the time response, because I'm hoping that you have covered the course. Okay. So you have to compare with the standard second order system. What is the standard second order system? S square plus 2 zeta omega ns plus omega n square. Omega n is called the natural frequency of response. Okay. Zeta is called the damping ratio. Okay. So whatever in the denominator, S square plus 3S plus G, you compare with this standard form. Okay. If you compare now, you can see that your omega n square is now equal to Sg. Okay. And your 2 zeta into omega n, this term is equal to your 3. So these 2 points you can find out by comparing these two equations. Coefficient of the S, coefficient of the S square, and the coefficient of the constant, you just compare and equate to each other and find out this equation. Okay, equation number 1, equation number 2. Okay, so clearly in this question it is asking that the step response. Okay, this is step response, because whatever the response is coming here, it is settled around 1. Okay, 1 is called a unity step response. Okay, so you can see there is a peak and then there is a valley, then it is settling. After some settling time, the response is settled to 1. That's why always what the output is always try to catch the input in a control system, that we are doing. Okay, so here whatever the output is now little bit oscillating initially, then it is settled down to the input is a step response. Okay, so now for first question is over, you calculated the transfer function. What is the next question? The next question is that find the value of G so that the closed loop response of the step input as shown in figure B. So he is asking us to find out the G value. Okay, so from this, can you find out the G value? Can anyone tell me what is this peak overshoot value? From here, peak overshoot is means from your input how much your peak is going. Input is 1. From 1 you are moving to 1.5266. It means your peak overshoot is now, I'm not writing in percentage, I'm just finding out the absolute value. The peak overshoot is now 1.5266 minus 1 is 0.5266. This is a peak overshoot, and there is a formula. Okay, the peak overshoot is nothing but e to the power minus pi zeta divided by 1 minus zeta square is your MP. You know MP value, you know zeta value. Okay, no, you know MP value. Solve this equation to find out zeta. Okay, zeta you find out. Once you find out zeta, now you solve this equation on 1 and 2. okay, to find out G value. Okay. But there are lots of shortcuts are there, okay, in time response analysis. But the time is not permitting me to tell all the things now, okay. So you read by yourself, okay. And one famous question, just I will give one question I will solve. I think by using that one question, you are able to get a deeper understanding of the time response. Any question that will be come from the time response, that you can able to find out. Okay, let me do here for you. Okay, just give me 1 second. I'm sorry. So now in this question, if you find out omega n and zeta value, okay, and then you can able to find out the G value. Okay, so now you solve by yourself and tell me what is the value of G. Okay, you solve by yourself. Okay, let me go to the question I just wanted to point out here. Let's say you are solving any time response question. Then remember that in time response question, the closed loop transfer function C of A by R of S. Okay, let I'm writing something G divided by S. Let I'm writing G equal to 1. S plus 3 square plus 16. But whenever you're going to solve the time response question, remember that we are always interested in the denominator part, because from that we are able to find out the stability of the system. From that we are able to find out the peak overshoot, delay time, settling time, all this. So our interest is that you have to look the closed loop system denominator part. So what is the denominator part here? S plus 3 whole square plus 16. Make it equal to 0, because this is called the characteristic equation. Okay, so once you know this characteristic equation, you find out the pole location. How to find out the pole location? So you solve this equation, s plus 3 whole square equal to minus 16. Okay, then tell me what is the value of s equal to minus 3 plus j4. Another one will be, because second order system, that's a minus 3 minus j4. Okay, so these are the two poles. Once you solve it, you will get these two poles location. Okay, so remember that you first draw that pole location. So one pole, let's this point is minus 3. So one pole will be located here. This distance is j4 and this distance is minus j4. Let me locate another point here. These are the two poles. Okay, these are the two poles now. These are complex conjugate poles. Okay, so now what you do, so you connect this point to the origin. Connect this point to the origin. Okay, now in if you solve this equation, s square plus 2 zeta omega ns plus omega n square, then you will get two pole location. What are the two pole location? S1 equal to minus zeta omega n plus minus j omega d. Okay, damped frequency of response. Omega d is nothing but omega n into 1 minus zeta square. Okay, so you remember in this way, S1 is S2 equal to minus zeta omega n plus minus j omega d. So if you see here and compare what is minus zeta omega n here in this question, minus zeta omega n is minus negative part, na? This is the negative part. So
minus
zeta
3, sir.
omega n equal to 3. What is omega d? Omega d equal to 4. You try to understand these two. How can I write from directly? How can I write zeta omega and omega d? Okay, then whatever you d, you just, this is a Pythagoras theorem apply. This is 4 and this distance is 3. This hypotenuse will be 5. This 5 is nothing but your omega n. Okay, omega n equal to 5. Because why? These two poles always tries to move in a circle, and that circle having a radius always equal to your omega n. Okay, so this always moves with a radius of omega n. This omega n is a constant, that is called the undamped natural frequency. There is no damping. It is always rotating at a constant, that is called amplitude. There is no damping. Damping means what will happen? This magnitude will be reduced. Okay, this value omega d is coming into picture. That's why this omega n can you can see directly that by solving this minus 3 plus j4, you can directly say that the hypotenuse will be 5. So omega n equal to 5. Omega n you know, zeta omega n you know, you find out zeta. Zeta is nothing but 3 by omega n, 3 by 5. Zeta you know that 0.56, 0.6. Zeta you can easily find out. If you know zeta, omega and everything, then delay time is nothing but you can find out, rise time you can find out, settling time you can find out. Okay, so in that way you can find out lots of questions you can solve, able to do by using this Pythagoras theorem and making a triangle like that and find out the pole location. Okay. So in this question actually they are also find the value of g. Okay, we already calculated the value of g. Then find the value of Ts and Tp. Ts is called the settling time. Okay, because he is giving for a 2% tolerance band. For 2% tolerance band, the settling time is 5 times of zeta omega n. Okay, Ts is nothing but, can write out 5 times of T. What is T? Can anybody tell me? What is the T? T is not natural time constant. From this location, what is the T? T is nothing but this distance. This distance is your T. It means what is the distance here? Zeta omega n. Okay, this in frequency convert into T. T is nothing but 1 by zeta omega n. Okay, if it is asking you to find out what is the settling time, this is 5 times of time constant. So 5 divided by zeta omega n. Okay. What is Tp? Tp is called the peak time. Peak time formula is how much? Pi divided by omega d. Once you know omega a and zeta, then omega d is what? Omega d is this distance only. Don't calculate any formula, because people should write here omega n into 1 minus zeta square, everything. But don't do that. Omega d you already calculated. Omega d is nothing but this coefficient of this j. Okay, this is called omega d. So omega d is 4 for this question, means whatever the question I given to you. So this will be pi by 4. So like that you find out Ts into Tp. But the original question is something different. Okay, G you calculate, find out omega n, solve this question like that way. I'm just giving an example. Okay, everything, I think everyone, this 10 question I prepared for today. Okay, if you have any doubt, okay, you can ask me in the next class. Okay, but we practice some question related to time response. Okay, like how to solve Mason's formula, how to find out the steady state error. Nowadays steady state error will be easy for you to solve the questions. Then you can go for time response. Time response is a vast syllabus. I cannot complete all the questions here, but better you go to the classes and try to solve as many and numerically and try to solve and apply concepts. Okay, write a diagram, make a diagram, find out omega and find out the pole location. From the pole location you find out all these parameters. Don't use any formula. Okay, anything. So, okay, I'm just stopping here for today, or we'll meet in the next. Okay. So, if any doubt,
Hello.
yes, yes, tell me.
Sir, can you suggest me, sir, how I get the previous year questions, sir, of
Previous year
control engineering?
questions. Previous year question means
Like, sir, in 2024, 2023 control engineering papers, sir.
I think you cannot get it because you have to enroll for that. I don't have that question also with me. Okay. So if someone is enrolled, your friend has enrolled, then I think in his portal it will be there. Okay.
Okay, sir. Thank you, sir.
Okay. Thank you. Thank you so much. Any other questions are there?
Thank you very much, sir.
Okay. Thank you so much. All of you have a
Thank you, sir.